Okay, guys, here we are with running test review, page 5. We've added proportions to this one. It seems like proportions haven't been too hard for most of you, so if you can remember, a basic proportion is solved by cross multiplying. This first one just does the cross multiply with you. You're going to get 10x equals 42 times 30, which is probably a calculator problem. So we get 1260. Then to get x, we just divide by 10 on both sides. We get x equals 126. This time we have a word problem proportion that deals with percentages. As soon as you see 12%, that should tell you, you always put that number over 100. So we say 12 over 100. And then the other part of this says 1,482 students in the school. Well, if there's 1,482 students in the school, what you're looking for is how many are absent. So basically, you know there's 1,482 total. That means 100% of the students, 1,482 should go on the bottom because it corresponds to the 100%. And then the missing number, the absent students, would go here. So again, we cross multiply to solve this one. Like that, and we end up with 100x. We're going to get a really big number here. 12 times 1482 is 17,784. Then we divide by 100 to get x by itself. That gives us 177.84. The problem with that is that we can't have 0.84 of a student, so the most we can get is 177 as the best possible answer. This time we're dealing with a proportion that talks about a 20-foot tall building, and it relates the height of that building to its shadow. So if we talk about the building, we're going to say 20 feet over a 12-foot shadow. So then on the other side of this proportion, we want to relate the person's height to the shadow in the same way. And so what we're missing is the height of the person, and we have the height of the shadow. So I just put these little units in here to remind me of what I'm dealing with, and so the relationship is the same on both sides. Basically, as you can see, it's the height of the building over the shadow height. Here, the height of the person over the shadow height. Same concept on both sides. So we cross multiply. We get 12/8 equals 70. And in one step, we can divide by 12 on both sides to get 8 equals 5.83. Our answer is that. So we're going to move into section 2.3. This is on graphing linear functions. So there's a whole host of different ways you can do this, but basically what you know is you're going to be graphing a straight line, so you should be trying to have 2 points to do it. So sometimes, as in the case of number 46, they just flat out give you one of the coordinate points you're going to graph. So go ahead and plot 0, -3. That's over 0 and down 3. And then in this case, we don't have a second point, but we do have a slope, which is 2 over 1. We know that is rise over run, so this is up 2 and right 1. So from the point I just plotted, I'm going to go up 2 places, and right 1 place. And I can put another point in there, right where I stop. And then I can draw my line. Just like that. And I'm done. Right, for 47, you have an equation this time. And because the equation is not set up in y equals mx plus b format, you can either choose to rearrange it like that, or maybe the easier way is to try to do this by y and x intercept method. So if I want the y-intercept of this thing, basically what I'm going to say is I'm going to forget about the x term entirely and just work with the y. Make it -2y equals -6. And in one step I get y equals 3. So the intercept for the y-axis is 3. That means I can go to the y-axis and put a point where positive 3 is. That's it. And then for the x-intercept, it's basically the same idea, except this time I'm going to forget about the y term and just make it 3x equals negative 6. And if that's the case, x equals negative 2. So on the x-axis, I'm going to put a point where x is negative 2. And since I now have 2 points thrown in, I can go ahead and draw my line. Like that. Okay, this time we have two problems that are dealing with the same kind of setup. We have equations that are a little more complicated and ask you to write them specifically in slope-intercept form, which is y equals mx plus b. So right now, essentially what we're saying is we need to get y by itself. We need to get rid of all this other stuff. So the first thing I'm going to do is subtract this 4x away because it is positive 4x, and it doesn't need to be there. So I get negative 3y, and then I'm going to put the x term first, so negative 4x and a negative 1. And then in the next step, I'm going to get rid of this negative 3 that I don't want either. That's negative 3 times y, so I'm going to divide by negative 3. And basically these cancel to leave me a y, which is what I want. So y equals, here we have negative 4 over negative 3, that's positive 4/3 x. And negative 1 over negative 3 is positive 1/3. So we have a little bit of issue with some fractions here, but a fraction slope is actually good. On the other hand, a fraction y-intercept is a little bit of a pain. We can deal with that. Let's take this 1/3 right here and plot it on our graph. Now that's where y is 1/3. So it looks like I'm going to have to estimate that a little bit, but it would be right in here somewhere. And now I'm going to use the slope, which is this one, to go up 4 and right 3 from this spot. So here I go, up 1, 2, 3, 4, and right 1, 2, 3 here. And so I can plot a new point right there. And now I have my 2 points, so I can go ahead and draw my line. So when you're asked to put two graphs on one, it's a good idea to label them. So I'm going to say this is number 48. Like that. Okay, and if we look at the next problem, it's the same concept. Again, we want to have y by itself. I want it to be in slope-intercept form. So y only. So first off, I have this negative 3x I want to get rid of by adding 3x to both sides. But that leaves me with a negative y, a positive 3x here, and a minus 2. So you can think of this last step here as dividing by a negative 1 if you want. Or basically, if you can remember that I don't want a negative y, I just want a y. But if I change that sign, I have to change the sign of everything here. So now negative 3x and positive 2. But at that point, my equation is done. So I need to graph it. Well, I want to put the y-intercept right here on the graph. So I need a point at y equals positive 2 right there. And I also want negative 3, which means negative 3 over 1. That means down 3 and right 1. So from my y-intercept, I'm going to go down 3. 1, 2, 3, and right 1. I'm going to put a point right there. Now I'm ready to draw in that line. Now you can see that number 49's line is a lot more steep, and it's definitely downhill. That makes sense because the slope was negative, and for 48, the slope was positive, so it was uphill.